No, I'm on the wrong page. One part, not the part one, and number two, not the part one, wasn't that it? Right, okay. One, will I do it? I know we just started it, so will I do number one, or was number one okay? Will I do part two? Yeah, okay. So part two is 2 times cos 5 pi over 6 plus I sine 5 pi over 6. So that's a complex number written in polar form. So they want you to turn it back into Cartesian form, back into x plus yi, right? So 5 pi over 6, right, remember, that's an angle. So when it's an angle, that's 5 times 180 divided by 6.
Yes, it's not focused.
Sorry, it's not focused, apologies. Right, 5 pi over 6, so it's 5 times 180 divided by 6, okay? So remember, pi when you're talking about an angle is 180, is that right? Okay, and make sure your calculator is in degrees mode, as in there's a little d up at the top, okay? So if that little d could be an r or it could be a g. If it's an r or g, we have to change it, okay? So we want it in, d is for degrees, we want it in degrees mode, okay? So 5 times 180 divided by 6 would be 150. Is that okay? Turning that into degrees. So that would be 2 times cos 150 plus I sine 150. So into the calculator with that, get cos of 150. You'll have to help me out. Cos 150 minus root 3 over 2. And sine of 150, a half, okay, and then multiply into the brackets by 2, so 2 times root 3 over 2 is just minus root 3, the 2's cancel, and 2 times a half is 1, so that's I. That's your answer. Is that okay? Right, does anyone need me to do another one of those, part 3 or 4, or do you think it's okay? We're okay? Right, okay, then part 2, right, I'll do one out of part 2 anyway at least, right, part 2, it says, represent each of the following complex numbers on an Argand diagram, indicating the modulus and argument.
If I could have your attention for a few moments, please. And as we pause to pray today, let us continue to pray for peace in our world, and especially in the Ukraine at this time. And today, the 30th of March, marks the anniversary of the founding of the Sisters Faithful Companions of Jesus. Marie-Madeleine Douay founded the congregation in Amiens, France, on the 30th of March, 1820. Like all new projects, she would have had many struggles in establishing this new order. Yet, she never gave up. And as we listen to the verse, don't quit, let us be prepared to hold on to our dreams, especially when the going is tough. And as Rachel Blackmore said last week, after she had won the Gold Cup at Cheltenham, you can never dream too big. Don't quit. When things go wrong, as they sometimes will, when the road you're trudging seems all uphill, when the funds are low and the debts are high, and you want to smile, but you have to sigh. When care is pressing you down a bit, rest if you must, but don't you quit. Life is queer with its twists and turns, as every one of us sometimes learns. And many a failure turns about, when he might have won had he stuck it out. Don't give up, though the pace seems slow. You may succeed with another blow. Success is failure turned inside out, the silver tint of the clouds of doubt. And you never can tell how close you are. It may be near, and it seems so far. So stick to the fight when you're hardest hit. It's when things seem worst that you must not quit. So let us go about our day to day, determined to hold on to our dreams and to do what we can to achieve them. And we make these and all our prayers through Christ our Lord. Amen. In the name of Father, and of the Son, and of the Holy Spirit. Amen.
Okay, so I'll just quickly go through all of number 2. So part 2 is minus 3i. So if I was to draw that on the Argand diagram, so minus 3i is across 0 down to minus 3. Okay, is that right? And it says just indicate the modulus and the argument. So the modulus is, you don't even have to use the modulus formula. It's how far it is from the from the origin. So how far is it from the origin? 3, isn't it? Okay, you could use the square root of a squared plus b squared, and it'd be 0 squared plus minus 3 squared, which would be 3. Okay, but you can see from the diagram it's clearly 3 units from the origin, yeah? Okay, and then the argument is the angle it makes with the positive x-axis. So all the way back to the positive x-axis. So what would the argument there be? Without measuring anything? 270, isn't it? It's from here to here is 90. From there to there is another 90, and back here is another 90. So 3 90s are 270 degrees. Is that okay? That's all they wanted you to do there. Right, the next one, right, is 4. Right, okay, so it's just 4. So that's 4 plus 0i. Remember, 4 on its own is 4 plus 0i. So it's across 4, and it's up 0. So 4 plus 0i is right there. Okay? So the modulus is how far is it away from the origin? How far is it away from the origin? 4 units, isn't it? Right? And theta then is the angle it makes with the positive x-axis. Right? It's on the positive x-axis, so it clearly makes an angle of what? 0. Would you agree? Okay, so 0. Okay, so that's part 3. And then the final one, right, is part 4. We'll have to do a bit of calculation on this one. So it's minus root 3 plus I. Okay, so if you were to draw that, okay, so it's across to minus root 3. So minus root 3 is minus 1 point something. So minus root 3 and up to 1. So it would be here. So it's across, sorry, it's up as far as 1. Right, okay, and here is root 3. Is that right? Are we okay with that? So the modulus is the distance between that and the origin. Okay, you have to use the modulus formula or the distance formula using minus root 3, 1 and 0, 0. Or you could use the modulus formula, which is the square root of a squared plus b squared. Right, so a squared is the real bit. So it's the square root of minus root 3 2b squared, and b is the number in front of I, which is 1 to b squared. So that would be the square root of 3 plus 1, which would be 4, which would be the square root of 4. So that means the modulus is 2. Is that okay? Are we good with that? Right, now the argument is all the way back to here. Okay, right, it's the size of that angle there. Right, my right angle triangle, right, that I have is, it's across root 3, it's up 1, and it's 2. So this is the right angle triangle in here. I just drew it bigger. Okay, just give me, I bet you this is dried up. No, it's not too bad. Right, see the right angle triangle? Okay, is that alright? Now I'm going to get the size of that angle there. That's not the argument though, right? Sure, it's not. But if I know that angle, I can get the argument. How would I get the argument? If I know this angle, the blue angle. If I know that angle in there, how would I get the argument? You would subtract it from 180. Do you see that? Okay, so I can get the angle in here. So I'm just going to call that angle X. Right? Angle X is not the argument, because the argument is the size of the angle between the complex number and the positive x-axis. So I have to subtract it from 180. Right? Okay, so getting the argument there, you can use sine, cos or tan. Right? Either or. I always use tan. Right? The reason I use tan is in case I have the modulus wrong. So this is the opposite, this is the adjacent, and this is the hypotenuse. Right? Okay. So I can say that tan of x, tan of angle x equals opposite, which is 1 all over adjacent root 3. 1 over root 3 inverse tan of 1 over root 3, and you get, someone might give me it because by the time I get it open, you'll have it told me 4 times over. Anyone? Was it? 30. So x is 30 degrees. X is not the angle I'm looking for, right? The angle I'm looking for is here, okay? So this is 30 degrees. So what's the argument of that? What would the argument of that be? It would be 180, take away 30, agreed? So that means the argument of that would be 150. Are we okay with that? Now, they didn't ask me to express it in polar form, but just say they asked me to express that complex number, which was minus root 3 plus I. Imagine if they just said express that in polar form. In polar form, it's r times the cos of theta plus I sine theta. You've the hard work done. You found out that r is 2, and you found out that theta is 150. So that's cos of 150 plus I sine of 150. Is that okay? And that's if they asked you the extra bit, which they're going to ask you in number 3. Yes? Is theta the same as? The argument. Theta is the argument, yeah. Okay, they call it theta. It's just a Greek letter. Okay, is that alright? Okay, they didn't ask me for the last bit. All they asked me was for theta and for 2. Right, the modulus. Yes? Yeah, you can leave it in that form. In the back of the book, it'll be in terms of pi, like they'll call 150 5 pi over 6. Right, but we don't need to worry about that. Just leave it in degrees. Right, that'll do us fine. Okay, is that alright? Okay. So what I'm going to do is do a few more examples of these, right, okay, and then we will do some more of them for homework, okay, right, so express minus 1 over root 3 I in polar form, okay, will you remind me to change the roll there before the end? I keep going now, I'm on a roll, okay, so when you want to express a complex number that's given to you in Cartesian form, when you want to express it in polar form, you need to get 2 things. You need the modulus and you need the argument, which is theta, right? So you need the argument, right? You need to sketch, right? Okay? So in order to see where it is, right, you need to sketch. So sketch first, okay? Because you need to know where on the plane it is. Right, okay, so it's across to minus 1 and it's up to root 3, right, so root 3 is a bit past 1, so that'd be root 3 is in there. So it's across to minus 1 up to root 3, there's the complex number, right, that's where it is, okay. So remember, r is the length of that line, right, and the argument is all the way back to the positive axis, the positive x-axis. So that's the argument there, okay? So that's theta, is the argument, and r is the modulus, okay? Right, the modulus is easy get, isn't it? Right, the modulus is the square root of a squared plus b squared. So a is the real bit, so it's minus 1 to be squared. B is the number in front of I, which is root 3, all to be squared. Into the calculator with that, press equals, and you get 2. Right, you'll get r is equal to square root of 4, which is 2. So the modulus of that is 2. Right, okay. The next thing you do is you draw your right angle triangle. So you have to get a right angle triangle in here. So if you just draw that down there. So you're using your x and y coordinates to get you a right angle triangle. So it's across to minus 1, so that means that line measures 1, not minus 1. Okay, just it measures 1, remember, we're just putting in the measurements. And this one measures root 3. Okay, so it's across to minus 1, but it actually measures 1 unit. Okay, So don't put in any signs, never put a negative sign into your triangle because it's measurements. Okay, I'm going to get this angle here. I'm going to call that x. Right, that is not the argument. Sure, it's not. The argument is all the way back to the x-axis. But if I know this angle in here, so if I know the blue angle in here, how do I get the argument? Subtract it from 180. Is that okay? Right, so you can't, you're not able to get the argument directly because the argument is not in a right angle triangle. Okay, so you have to calculate the angle that's in the right angle triangle and then use that to get the argument. Use that in your diagram to get the argument. Okay, right, so I'm going, this is opposite and this is adjacent. I'm always going to use 10. So tan of x is equal to opposite, which is root 3, over adjacent, which is 1. Right, so then you get the inverse 10 of root 3 to find out what the angle is. When you get the inverse 10 of root 3, you get 60 degrees. Okay? Now remember, that is not the argument, right? So the argument of that complex number is 180 take away 60. And you need the diagram to figure that out, because sometimes you'll be adding it on to 180. Sometimes you'll be taking it away from 270. Sometimes you'll be adding it to 270, etc. Okay, you need the diagram. So you need the diagram to see where you are on the plane. Okay, so that means the argument is 120 degrees. So then in polar form, which is what the question said, it's cos theta r multiplied by cos theta plus I sine theta. Okay, and r is 2, theta turned out to be 120 plus I sine 120. And you can check your answer, can't you? Because in your calculator you can get cos of 120 and multiply it by 2, and you could get sine of 120 and multiply it by 2, and you should end up with minus 1 plus root 3i. Okay, is that right? So you know you're right. Okay. Example 4. Right, okay. Example 4, I'm going to change it because I did something like that in the homework. So I'm going to change this to what do I see? Minus 3 minus root 3i. Okay, so I'm just changing that to minus 3 minus root 3i. Okay, is that right? Okay, so I need to find in polar form, that means I need the modulus and I need the argument, right? In order to get the argument, I need a sketch. Okay, so draw my axis. Okay, minus 3 minus root 3 would be cross minus 3 down to minus root 3. It's not drawn accurately, okay, but there we are. Okay, so join it to the origin, right? Okay, and then draw in your theta. Theta is all the way back to there. Okay, so the modulus is easy. R is equal to the square root of a squared plus b squared. So it's just a formula that you'll remember because it's not in the log tables. So R is equal to square root of minus 3 to b squared plus minus root 3 to b squared into the calculator with that. Okay, so that's 9 plus 3, which is root 12, which is 2 root 3, I think. On the calculator, it'd be the square root of 12, okay, which is 2 root 3 on the calculator. Is that okay? Now, in order, let's have a look at the diagram, right? I can get my right angle triangle. I need a right angle triangle, so look at my right angle triangle. My right angle triangle is going to be there. Agreed? Right? So I'm going to get the measure of that angle there. Now, how do I go from the measure of that angle to the argument? What will I need to do? I needed to add it to 180. So that's what the diagram is for. Am I to add it to 180? Am I to subtract it from 180? What am I supposed to do? Okay, that's what your diagram is for, right? So you can see what you're supposed to be doing. Okay, so I'm just going to draw out my right angle triangle. So I'm going to draw out my right angle triangle there. So it's across to -3, so that means it's 3 units across. And it's down to -√3, so that means it's √3 units down. Okay, and I'm going to call this angle X. The reason I'm calling it X is because it's not theta, it's not the argument. Okay, this is the right angle, so this one is beside the angle, this one's opposite to the angle, right? I'm always going to use 10. So tan of X is equal to opposite, which is √3, over adjacent, which is 3. Then you get the inverse tan of that on the calculator. So inverse tan of √3 over 3, and you will get 30, I think. Yeah. $30, am I right? Okay, right. That is not the argument. That is the measure of this angle in here. So that angle in there measures 30. The argument is all the way back to the positive x-axis. So what have I to do to get the argument? I have to add it to 180, don't I? So it's 180 plus 30, which will be 210. And as I keep saying, you need the diagram to see, are you to add it to 180, subtract it from 180, what are you supposed to do? The diagram will tell you, right? Okay, so then you write it in polar form, which is what the question was. So it's r times the cos of theta plus I sine of theta. So the r was 2√3 and theta turned out to be 210. So it's the cos of 210 plus I sine 210. And at the back, that 210 will be written as 7 pi over 6, but don't worry about it, right? We're perfectly correct to leave it in degrees. Okay, is that all right? Okay. One more. Again, it's too easy. I'm going to go change it to, let's go with, I want to get one that's slightly different. A half minus √3 over 2i. Sorry, were you all finished example 4? Does anyone need that? No one's speaking, so I'll take that as a no. Okay, so I need to get the modulus and I need to get the argument to put it in polar form. The modulus, right, is fine. It's the square root of a squared plus b squared. So that's r is equal to the square root of a half squared plus minus √3 over 2b squared, and I think that turns out to be 1. It's a quarter plus 3/4, yeah, 1. Square root of 1 is 1. Is that right? So the modulus turns out to be 1. Then I need a sketch, right? Okay, so sketch is across a half. So across a half would be here, across to plus a half, and down to minus √3. Okay, so that would be, it would be down there. Across a half, down to minus √3. It's clearly not drawn accurately, that's fine. Okay, this one, there we go. Right, so I need the size of this angle all the way back. Okay, so I need the size of that angle all the way back. Right, and look, if I draw my right angle triangle, that's where it is. So I'll be getting the measure of that angle, right? So I'll be getting the measure of that angle there. That's the angle that's in the right angle. So how do I get the argument, which is all the way back? What would I have to do? It's almost a full circle. The bit I'm going to calculate is the bit missing out of the full circle. So what would you do? Take it away from 360. Is that right? So you take it away from 360. Let's draw the right angle triangle. So to cross a half, sorry, that is root 3 over 2, not root 3. So it's down root 3 over 2. Please note, they're measurements, so drop the minuses. Okay? And I'm going to get the measure of this angle here. I'm going to call that angle X. Okay? This is the opposite, this is the adjacent. I'm always going to use 10. Right, then I had a system. So tan of X is equal to opposite, which is root 3 over 2, over adjacent, which is a half. And when you simplify that, that's root 3. So tan of X is just root 3. You have a calculator. So tan of X is root 3, and then you get the inverse tan of root 3, which means X is equal to 60. Sorry. So X is equal to 60. Right, okay. How did I say I'm getting the argument? X is not the argument, right? So that's angle in there is 60, but I need all the way back. So how do I get the argument? What do? Take it away from 360. So it's 360, take away 60, which would be 300. So your argument is 300. And then you write it in polar form. So it's r times cos theta plus I sine theta. So r turned out to be 1 and theta turned out to be 300. So it's cos of 300 plus I sine of 300. Job done. And as I say, you can check your answer. Put it into, get the cos of 300 and see if it's a half. Get the sine of 300 and make sure it's minus root 3 over 2. Okay? Got it? Right. Okay, so I will give you these for homework now. I'm going to do some of them as my examples. So let's do page 28. Let's do all of question 3 except part 8, because I just did it. So except the last part, right, okay, and let's have a go at all of number 4. You have to do a bit of multiplying or dividing in number 4, and then you have to get it in polar form, okay, right, so all of number 3 except part 8 and number 4, all of number 4.